Michelle, here at NASA, we have, I don't know, millions of acronyms.
Millions.
Medli. What is that? What does it stand for?
Medli is actually an acronym within an acronym, so we're doubly bad. Medli is the Mars Science Laboratory, MSL, Entry, Descent, and Landing, EDL, Instrumentation System, so MSL, EDLI. And Medli is a series of sensors that will measure the temperature and the pressure on the heat shield of MSL as it flies through the atmosphere. And this is the first time we've ever been able to gather such a comprehensive, calibrated data set that's going to help us predict better in the future how to design our vehicles.
As chief engineer, what's your primary responsibility?
Well, my responsibility is to make sure that the flight hardware is designed, tested, and qualified for space.
Now, essentially, I mean, you're getting your hands dirty and your feet dirty in this whole project.
Well, yes, I'm with the nuts and bolts, but we don't like to use the term dirty because all of this hardware has to be very, very clean.
Well, that's that's true. Now, we have pretty much all the hardware that's going on into the heat shield for Medli. Tell us a little bit about each of the components.
Okay, so Medli consists of about 77 individual pieces of data from sensors that spread out through the heat shield. So half of those pieces of data are thermocouples.
Okay. That's temperature readings?
Those are temperature readings.
Okay.
This is called the Medli integrated sensor plug.
Okay.
Okay, and this is actually a piece of the heat shield. So
this material right in here.
This is the Pica material, and this is embedded in the heat shield. It's integrated. Most of them are put where they expect the peak heating, which is going to be towards the aft side as it's entering the atmosphere.
Okay.
So we have the higher concentration towards the rear. Along with the thermocouples, there's a recession sensor in here, and that measures how much of this is burning away as it enters the atmosphere. The heat shield actually burns away, and we'll be able to measure how much of that burns away along with the temperature reading.
MSL is bigger than any heat shield we've sent to Mars before. It has a new thermal protection system material on the front, and the flow field is probably going to behave differently than any other spacecraft that we've sent. And so all those new aspects of MSL made it especially important to gather data. And as we send these bigger and heavier things to Mars, we want to better understand how our tools are predicting so that we can design better in the future. And so obviously when we send humans to Mars, we're going to need to send very big, very heavy vehicles. And so Medli and MSL are really the first step on the path to understanding the human scale systems.
The other instrument, we have 7 pressure transducers, and this is actually a cutout of the heat shield. Now, we don't have the thermal protection layer on here. We don't have
the Pica material
on here, but this is actually what this transducer looks like on the heat shield. So these are mounted, and they measure the pressure as it enters the atmosphere. So right now, they're measuring the vacuum of space. As soon as we start hitting the atmosphere, we start seeing pressure, that's what we're going to record. We'll be able to see the entry characteristics of the spacecraft, and we'll be able to get some data on the density of the atmosphere.
Now, measuring the density of the Mars atmosphere, would it actually change from mission to mission the way that the spacecraft enters the atmosphere?
It does. The density has an effect on the mission design in several ways. So one, density varies with time of day and season, just like it does here on Earth. Actually, in the upper atmosphere, it's very variable because Mars' atmosphere is so thin and it has dust in it that when the sun heats the dust raises the temperature of the atmosphere overall, and the atmosphere actually expands and does what we call blooming. And so it's important for us to understand if we're going to arrive in a dust storm and if there's going to be blooming of the atmosphere, because then that will mean we're flying through more density from the top of the atmosphere to the bottom, and it affects our landing ellipse and also the altitude at which we can land. So if we have a totally different understanding of the density, it may mean that we could land on top of a mountain as opposed to the bottom of a crater. And that's very important for the scientists who are trying to get to that one specific spot.
Now, what does it take to make sure that all this technology, all this hardware is certifiable for space?
Well, we have to put it to the extremes of the environment that we expect it to see. For instance, all of these are mounted to the heat shield. The heat shield is the coldest part of that spacecraft. And right now, some of the areas of that heat shield are about minus 100 degrees C.
Wow.
So we've qualified it in this thermal vacuum chamber.
Okay.
the pressure transducers were qualified down to about minus 120 degrees C and up to about plus 50 degrees C. This sensor support electronics will not get that cold because it's setting next to the rover. There's a lot of other electronics that's keeping it warm, but still we had to take it to the extremes with margin to make sure that it can handle it. And it goes through days and days and days of cycling in this facility of hot to cold to hot to cold, back and forth, just to qualify it.
So when you talk about the different variables that you encounter during entry, how do you actually test the components in Medli to withstand those extremes?
We have to do a lot of testing here on the ground, and a lot of the testing was done here at NASA Langley. One of the things we have to worry about is vibration, and we're actually standing next to a vibration table, and up here you see the pressure hardware as it was mounted for the vibration test. So we have to test that the assembly, not only the transducer but the tube and mounted to the heat shield, all that holds together during launch and then during entry. So launch is our most stringent vibration environment, and then we also have vibrations during entry that aren't as severe.
We look at the entry conditions that this spacecraft went through, and maybe we're over-designing the heat shield. Maybe we're under-designing it and we've just been lucky. Either way, we want to know. If we're over-designing the heat shield, then that's extra mass that we can put into other instruments. If we're not under-designing it or we're right on the edge, well, we want to know that too, so we can add extra margin. So this is going to go into the next developmental cycle of whatever the next heat shield is going to look like.
And that makes sense because you can't really truly test that spacecraft here on Earth because we don't have the right conditions for a Martian atmosphere.
You absolutely cannot.
So you need to have margins built in case something happens.
Yes, and hopefully that there are so many uncertainties that go into sending a spacecraft to Mars, and we hope that this data will lead to reducing some of those uncertainties in the future.
What's it going to be like when you finally get the first set of data back from the spacecraft?
It's going to feel like such a sense of accomplishment, not just for me, but for all the people who've poured their hearts into this project. I'm really looking forward to that day.
Looking at all this hardware, you talked about you had to bake it in the thermal vac?
Everything has been baked. It's super clean. We bake it in this class 10,000 clean room, and so it's all at a very high level of cleanliness.
Is it like a pizza flavor?
No, that's all super clean. There shouldn't be anything on it.
I don't know. It smells like pizza.
It does smell like pizza, yes.
Well, Chris, thank you so much for giving us the opportunity to talk about Medli, and actually, instead of saying good luck, at this point in time, we're probably going to be talking about the success.
Sounds great.
Hey, you're watching NASA Edge, an inside and outside look at all things NASA.